Everyone, today we are going to talk about quadratic equations. So what are quadratic equations? We have learned in term 1, we have learned about polynomials. So when a polynomial f of x, suppose we have polynomial f of x, this f of x is equated to 0, we get an equation which is known as a polynomial equation. So now there are different types of polynomial equation, like linear equation, then comes quadratic equation. Like we know this is an example of a linear polynomial equation because the degree over here is 1, the highest degree of the variable, this is 1. And similarly, when the degree is 2, it is quadratic equation. It's pretty simple. Now let us look at the general form of a quadratic equation. The general form of a quadratic equation is like this: ax square plus bx plus c is equal to 0, where a, b, c, these are real numbers, these belong to real numbers, and a cannot be equal to 0. A cannot be equal to 0, this is very self-explanatory, because if a is 0, a is known as a leading coefficient. If the leading coefficient is 0, then this would turn out to be linear equation. But we are talking about quadratic equations over here. So this is basically the general form of quadratic equation. Now let us look at some examples. These are some particular sums which we have to distinguish whether they are quadratic equations or not. So let us look at the first one. Here, if you write it like this, question number 1, it says x plus 1 whole square is equal to 2x minus 3. Right, now let us expand the brackets. This is x square plus 2x plus 1 equals 2x minus 6. Right, now we'll just transfer it here. So 2x goes off, and x square plus 7 is equal to 0. Right, so this equation when we are simplifying it, it's coming out to be this. So and we know that the general form of a quadratic equation is like this: it must have the leading coefficient must have a variable x square. So this is the leading coefficient. The leading coefficient over here is it's 1, and its x square is there. For a equation to be quadratic, x square term has to be there. Okay, so this basically this is a quadratic equation. So we'll write here y over here. Now let us look at Now let us come to question number 2 over here. Question number 2, we do not need to solve it. We can just use some multiply and see x square minus 2x, right? And here it will be minus 6 plus 2x. So x square term will be there. There is no other term to cancel out this x square term, right? So this will also be a quadratic equation. So number 2 is also a quadratic equation. Now let us look at number 3. Number 3, here we will simply just multiply this term with this term and this term with this term. Now look at it very carefully. All the coefficients, if we multiply this term with this, it's coming x square plus x square, and when we are multiplying this term with this, it's also coming plus x square. So on the left hand side as well as on the right hand side, we have a term x square which is positive, and the coefficient of that x square term is also 1. So x square goes off. And since in this, if question number 3, if we just solve this entire thing, if we simplify it, we will see that the x square term is not there. So since the x square term is not there, this will not be an quadratic equation. It will turn out to be simple equation. So we will say no, this is not a quadratic equation. Now we will come to number 4. Number 4 is also the same thing. Here if you multiply x with this, it's coming out to be 2x square. In the left hand side it is 2x square, and on the right hand side it is x square. So when this will come to this side, it will be 2x square minus x square. It will basically be like this: 2x square minus x square, which will turn out to be x square. So one x square term will remain in this equation, right? So question number 4 is also a quadratic equation because the x square term is there. So we will write yes over here. Now let us move on to the next question. The algorithm is simple. We just need to multiply the first 2 terms and just check like that. We do not need to do the entire calculation. So it's 2x square in the left hand side, x square in the right hand side. So this will also be true. This will also be yes, because the x square term is remaining in the equation. So this will be y. Now the next one, the next one are simple. This is very simple. It's x square over here. When we apply the formula of a minus b whole square to this, x square will go off. So this will be n. This is not a quadratic equation. So this will I'm sorry. This will be 2x cube, right? Here there is an exception over here. This is 2x cube. This, if we evaluate, it will be 2x cube. Here we will have a term x cube. So x cube minus 2x cube. Why minus 2x cube? 2x cube, because if this comes over here, then it will be x cube minus 2x cube. So basically minus x cube. A minus x cube term will be. So number 7 comes out to be n, because x cube term is there. Now let us move on to number 8. Number 8 is also, this will be, it's easy. It's the x cube is over here, and when we apply the formula of a minus b whole cube, x cube term will also be here. Both the x cube term gets off, and so there is no presence of x cube term in this entire equation. It will only be the x square term will be over here, and there will also be an x square term over here. So x square term remains in the equation. So this is a quadratic equation. Okay, so this is how we distinguish between an equation. An equation will always be quadratic if there is no presence of the term x cube by x to the power 4 by x to the power 5, and simple equation term should be there. It's okay. Like if just look at the general form, ax square plus bx plus c. This term has to be there. It's very important. This term has to be there, and these are okay. But a term with the higher power, with the higher degree than x square should not be present. This is the general form of quadratic equation. We just need to keep this in mind. Now let us move on to the next one. So this is, now we are to find out, suppose this is the general form, right? These are quadratic equations. So suppose we are asked to find out the value of x over here in this question number 1. We need to find out the roots of this equation. The equation of x square means there will be 2 roots. Okay, suppose x is equal to a and b. So if we put the value of a in this equation, then it will give us 0. If we put the value of a in this equation, the value of x as b in this equation, then it will also give us 0. So basically, if it's quadratic equation, means that it will have 2 roots, which means that it will cut the x-axis at 2